3.8. The n by n identity matrix is a matrix with ones on the main diagonal and zeros elsewhere. Now let's pause here a moment because they've mentioned an n by n matrix. That means the number of rows and the number of columns are the same. Okay, so an identity matrix has to have n by n. What's another word for an n by n? Square matrix. Okay, that's right. It's a square matrix. So let me draw a 2 by 2 identity matrix, and we call it capital I. A 3 by 3, and it's saying that in the main diagonal are ones, and everywhere else are zeros. Let's even go to a 4 by 4 so you can see the pattern. Okay, so this is called the identity matrix. And here's something else that's very, very interesting. If you take a matrix A times the identity matrix, it gives you A back. And it's also true if you took the identity times A, it'll still give you A back, okay? Because that's going to be very important in a moment. All right, good news. The inverse matrix, I'm not going to make you memorize this. We're going to end up using our calculator in order to determine a matrix, an inverse matrix. So in example 1, if I want to find the inverse of matrix A, which is 3, 8, 2, 5, I want you to take out your calculators, and let's go to second matrix. Okay, go second matrix, arrow to edit. Matrix A is a 2 by 2. So enter 2 by 2, and then let's enter the values. 3, 8, 2, 5. Okay, so you go second matrix, arrow to edit. A happens to be a 2 by 2 matrix, and you enter it. Now you have to get out of there, and you hit second, quit, second mode, and then watch what we're going to do. We're going to go back and pull up matrix A under names, and then here's the inverse key. It's beautiful because it's right on the same button as matrix. It's that x to the negative 1. You just don't press second. And so it's going to, the calculator is going to generate the inverse for us. So back to my notes, A inverse is negative 5, 8 to negative 3. Now you're going to have to wait for the punchline for why we're looking at the inverse, but you will learn that before the end of the lesson. So now what I want you to do is I want you to do letter B. This A is a 3 by 3. So let's go to the calculator. We're going to do second matrix, arrow to edit. This time A is a 3 by 3. Remember what I told you previously. Before you leave the matrix screen, double check your entry. Because if you don't, when there's no work to be shown on your paper for an inverse matrix. So unfortunately, that means there's no partial credit I can give. It's either correct or incorrect. So if you can pause here, double check you have your negatives in the right numbers. Okay. Now let's do second quit, and I want to show you a new feature of your calculator that maybe I showed you, maybe I didn't, I can't remember. So I'm going to pretend that I didn't. I want A inverse. So watch what you can do. Your calculator, if I press second enter, it pulls up the previous line so I don't have to type it again. Your calculator will actually, for as many times as you want, like say 3 lines up there was something you did and you want to do it again. You can press second enter, second enter, second enter, and it'll go up your screen as far as you would like, okay? Which is very helpful at times. So now I just press enter, and I want you to notice that there's decimals in here. And I don't want you to write decimals if you can convert them to fractions. And I'm not suggesting that you convert them. We're going to let the calculator convert. So while your matrix is up on the screen, I'm going to show you another feature you may or may not know. You press math. Number 1 stands for fraction. You press enter, and it converts terminating or repeating decimals to fractions. Isn't that awesome? So for part B, you do need to write A inverse. I get -12, -7, 3, -20, 12, -5, but then it's 3 halves, -1, 1 half. So convert decimals to fractions whenever possible. Yeah.
How did you do that again? How did you convert it?
You press, once your matrix is on your screen, press math. Number 1 says fraction, and just press enter and enter. Okay? Alright, everybody okay with how you can get the inverse? So very straightforward. You just enter the matrix, then get to your home screen and do A inverse. Alright, so then in example 2, what if I have a matrix equation? This is A times the unknown equals B. I want you to write a note here. In general, A times B does not equal B times A. Matrix multiplication is not commutative. And we talked about that last time when we were multiplying them, that sometimes the dimensions won't match up and it's not even possible to multiply in reverse. So, as I do this next piece, I need you to watch very, very carefully what I'm doing. If I have A times X equals B, and these are matrices, well, let me pause a moment, and if I said to you, what's 1/3 times 3? It's 1, right? Well, 1/3 is the inverse of 3, isn't it? 1/3 is the inverse of 3, and it's producing the identity. Now, when we're dealing with matrices and order matters, I can't squeeze something in between A times X, okay? But what I can do is I could multiply on the left side of A inverse, because A inverse times A gives me the identity. And what we learned on the previous screen is the identity times a matrix is that matrix. But what's happening on the left side of the right side of the equation, you have to put the A inverse on the left because I put it on the left of A. So that order matters. So the big idea here is when you have a matrix equation, A times X, and X is the unknowns, equals B, you're always going to do A inverse on the left times B, okay? So, and again, there isn't going to be any work on your paper besides A inverse times B. So here's what I want us to do. We're going to go to our graphing calculators and we're going to enter matrix A and we're going to enter matrix B. Okay, so let's do that together. So I'm going to do second matrix, arrow to edit. A is a 2x2. So then I have 2, -7, -1, 4. Pause and check your entries, because there's not going to be any work and it'll be unfortunate to miss all the points. So I don't want that to happen to you. So just pause, check your entries. Then I'm going to do second matrix, edit, and I'm going to go down to matrix B. It's a 2x2, so just press enter. And I have -21, 3, 12, -2. Now you have to get out of there, so you're going to do second quit. And we want A inverse times B is going to solve it. So I'm going to do second matrix, pull up A, and do the inverse, times second matrix, under name, B. So you're going to pull up A inverse times B will solve the matrix equation. And then press enter. So, the solution is 0, -2, 3, negative 1. Alright, and you do need to just hold on because I'm going to explain what all this stuff means when we hit example 4. But for now, we're just trying to pick up the process. So now what I want you to do is I want you to try example 3. This is AX equals B. So to solve this, you're going to put matrix A in, matrix B in, and then do A inverse times B. Okay? So try it. Alright, I'm getting -1, -2, 4, 1. Are you guys getting the same thing?
Yep.
Alright, awesome. Okay, so now why on earth are we doing this? Well, there's a really good area that we can use matrix equations, and it's with solving linear systems of equations. So what's going to happen is you want to write the system as a matrix equation where A represents the coefficients of the x's and y's, and B are the constants or the answer column. You find the inverse of matrix A and then do always on the left side A inverse times B. So let me show you this. This is so cool. So I'm going to make the A matrix the coefficients. So that would be 2, -3, 1, 4. Now the x represents the variables, and B are the constants or answers. So what you can do, you can actually take any system, and this would be awfully helpful with a 3x3. Remember how tedious those were to do, and we would make a little mistake, and it would be a mess. So on the next quiz and test, you're going to be asked to do it by hand one last time. Then after chapter 3, you may, anytime you see a 3x3, you can use a matrix equation, and we're going to solve it in less than a minute, which is amazing and wonderful. But let me go through, before we actually try to punch this one in, I want you to see how this really connects. Do you remember with matrix multiplication, you're taking that top row times the first column. So that's in fact 2x plus -3y, that's this, equals 19. The bottom row times the first column is 1x plus 4y equals -7. So this matrix equation represents the system of equations. But then all you have to do is enter A matrix, enter B matrix, and do A inverse times B. So go for it. Go enter A and enter B. When I did this, I got a 5 and a -3. Now that we've moved, though, from just a matrix equation to, this was a system of equations, right? These represent two lines that are intersecting. The other two were not, it wasn't a system necessarily. It could have been some other data that we were piecing together. But since this started out as a system, I know that a system of two lines really intersects in a point. So if you have this, where it started out as a system of linear equations, you do want to, go to a point. Yeah.
And then if x would have been on the second line, and then y would have been on the first line, would be if switch.
Uh-huh.
Okay.
Yes. Absolutely. All right, so here we go. Everybody okay? Let's try example 5 then. Watch that. I mean, this is like so awesome. All you do, and be careful with your negative signs. This is super easy. So the A matrix always represents your coefficients. Your X matrix is the unknown. So sometimes you could have ABC in there, and that would be okay, but you're still using the X is just your unknown, and B are the answers. So to solve this, you're going to do A inverse times B. So I'll give you a moment, and I want you to enter A is a 3 by 3 matrix, and B is a 3 by 1 matrix. And so since this is an ordered triple, remember to write it as an x comma y comma z. I got -2 comma 4 comma -1. So just check that you're getting that. All right, any questions? Again, -2 comma 4 comma -1. Now, I want to do a word problem here. Everybody got it? All right, let's look at this one together. It says, and you don't have this in your notes. This is just an extra one I added this morning. It says, a child in a neighborhood had a lemonade stand where large cups sold for 75 cents and small cups sold for 45 cents. On Saturday, a total of 78 cups were sold for $42.90. Let X be the number of large cups and Y be the number of small cups sold. A says write a system of equations for the number of cups sold, which we did this early on in the chapter. B says write a matrix equation, and C is solve the matrix equation. All right, does somebody want to try the system of equations using the X and Y? Andrew, what do you think?
Well, would it be like 0.75x plus 0.45y equals 4290?
Yep.
And then x plus y equals 78.
Awesome. Okay, and so looking at this one, with all those yucky decimals, wouldn't that be terrible to have to work out? So then what we can do is we can put this in a matrix equation. And it just makes our lives so much nicer. A is your coefficient matrix. B are the answers or constants. So then to solve it, you just are going to do A inverse times B. So you'll be asked to do this in your homework, and you will be asked probably to do this on the quiz and or test. And be careful with a word problem. You need to know what did you find. When you're ready, I found 26 represented X, which is the number of large cups sold, and Y is 52, the number of small cups sold.